What's up, guys? Use the extra noise from the bastard Goodman that's still here. It's pretty hot. It was 117 to 118 degrees yesterday, depending on who you ask. I saw 19 on the roof towards the end of the day after the peak yesterday. So today I think it was like 114 or something like that. Still hot. So I just got done hooking this up. And the good and the bad news. I just have a temporary cable over there just so I can hook the DC up. I haven't had a chance. So it indeed operates with both connected at the same time, like I knew it would. AC power coming in from right here, 230 volts AC. And then down here, just temporarily, I just got this disconnect right in here. There's DC, the 22 panels, 330 volts going to it, but we're not getting a lot of the sun is already going down, and it's what's it, 5 o'clock I think, 5:30. Yeah, so the sun's not over the panels, but it's still giving energy. So 15 amps, and if I unplug my DC, you'll see what it runs. There we go, 22 amps. So it's dropping at 6 amps. Damn, this is a piece of shit disconnect. It was free though. 14.9, 15. So it's dropping at 6 amps. Quite significant. It's dropping 25% of the current off of the line with the sun over there. I have the feeling it'll do a lot better when the sun is actually up and over. But that's the good news. The bad news is I noticed that when I decided to come and just do a checkup on this yesterday, and I just, now that it's ran 6 days, it's 5 days as of yesterday when I decided to put my meter on at home, I just noticed that for a 3-ton unit, 20 amps seems quite a bit. So single phase, 20 amps, 21 what it was right now, with the load and everything. And I'm pretty sure a regular single phase 3-ton unit would probably be more like 13 or 14 amps. So right now, I'm just bringing it down to what it should be, I think. So I don't know if it's just inefficient running a 3-phase compressor with a VFD. I could probably fiddle with some more settings. And I started to just a little bit when I got home, but it sucks right now. The sun's beating down on me. So let me go up there. Like I did change the threshold to go up to 70 hertz though, which is pretty interesting. Oops, not 70, 65. Ready? There it goes. 16.3 with the assist. Yeah. Can't do this one-handed. I take that off and run it all off the AC power. Look at that. 23 amps. Yikes. So, probably not benefit at all running it back in the 60 hertz. So you can make a 2-power meter on it. I tried a different, I have a expensive, like big ass frickin' amp probe. One actually made for VFDs, but this is just regular 60 hertz, you know, pure AC going in right here. This is the input from the house. And it was within a couple tenths of this one, so that is what I'm pulling off the system. This is a 3.5-ton, and yesterday I read it, and it was like 14, 15 amps. Now that compressor might have lost a 3-ton unit. It shouldn't be pulling 20 amps on the line side. It's weird that I actually changed the sound of that when I plug that in. Maybe it was my imagination. So watch the amps when I plug in the DC. It's gonna carry some of the load. If I get that on there, 21. This disconnect sucks to get lined up. There we go. Down to 15. So it's dropping like 6 amps even with the sun way down. So the solar panels will make more power when the sun's up. I'll do another test tomorrow unless something comes up. And I notice if I drop this thing to like 55. Hertz, drops the current down pretty good, just dropping 5 hertz, 14 amps. I'll have to go look at the chart I made that I recorded with my testo yesterday, and was kind of logging the time and everything. And drop it a little bit only raised the temperature coming out of my vent like a degree, you know, to go like down to 55 hertz, which drops it like an amp. It was more than an amp when I was on the, like an amp and a half on the AC side without the assist yesterday. And then if it dropped to like 50 hertz, it was dropping it quite more considerably. See right there, combined is 12.8, just dropping it all the way to 50 hertz. Now, I think I am going to stage this sucker after all, because it does seem to loaf pretty good. What are you doing? Come over here. Loaf pretty good when I slow it down to 50 hertz, especially like 45. I mean, 45. And, you know, I saw in the testo, you know, the suction pressure came up. Well, not like so crazy. So look at that. Combined goes down like 11. If I run it at 45 hertz like that, when the sun is up, I bet this thing will draw like 5 amps off my grid. On first stage, basic. So I'm going to 2-stage the thermostat. Probably do that in the morning before it gets hot. I think I might have to drop another cable. But right now it's hot, so I'll turn this up. What do you have to say? She's going to get political, I think, right here, my 10-year-old. What do you got there?
This.
What is it?
I read that first. I was like, oh, you know.
Come over here so I can go by the gate so I can hear you. You guys want to hear something? Someone with cerebral palsy, but then they have this kind of wit. She doesn't care for the things that most 10-year-olds do. What are you going to tell me about this? I know I don't know what you're going to say about that, but I have the feelings it'll be funny. What about that?
So is this going to be the next thing, the pollution? Because there it says, under Donald Trump, Arizona has some of the worst air pollution in the nation. Let's be clear, Trump's policies put Arizona at risk from air pollution and dangerous heat. How the heck did he do that?
I don't know. They said that it's Trump's fault.
Damn, look at this girl on the back here. I just want to point this out.
What is she wearing?
Is this the next thing they want us to do? Wear masks because of pollution?
Probably. What is she wearing? What do we call that?
A face diaper.
A what?
But that looks like...
What do you call it?
A face diaper, but that looks like
a diaper,
construction one, though.
Yeah, that is. It's for like painting or whatever. So it's kind of funny. Somebody get an N95 or anything. I was watching some good like 30-minute long video. It had a lot of details. They were showing like college and university tests and other independent like testing years ago, like 10 years ago, 15 years ago on dip masks, because some people voluntarily, like in China and stuff, you know, wear masks thinking it's gonna help them. And so back then, before it became political here, they were showing you that different testing, and wearing like a cloth mask makes you spread viruses worse. How about that? But that's what they're telling everybody to wear primarily here, and what everybody on the internet's all capitalizing on is what? Cloth masks. So, and then the diaper ones for surgical, I mean, they're only good for a little bit. And they're stupid, but...
That's not good.
Oh, do we have our address on there? Oh, man. I might have to, like, check the video later for that. This is 230 volt. Yeah, unless I change the unit out. See, because if I don't like the way this runs, and if it's kind of negating some of my efficiency, I mean, I think the solar is still going to carry a lot of the load, but if a regular single phase unit just is going to pull like 14 amps, you know, why would I, you know, and this, I'm only going to get this down, you know, like to 10 or a little under than that. I'll have to find out. Then what's the point? Especially at like when the sun's not up, it's going to be pulling more amps than the single phase unit. Doesn't make any sense, but you know, I didn't know there'd be that much loss or whatever with a VFD. I'll have to do some more checking on that, guys. That's kind of weird. Too pixelated to see the address? I hope so. So anyway, I wasn't very smart on that. We'll see. And maybe there's some testing, some stuff I could do to lower it just a little bit. You know, basically lower the pulses. Maybe it's overdriving it's because it's just a bunch of pulses that come out of these VFDs, so maybe it's just driving more than it needs to, and I can fiddle some settings and maybe it'll actually drop. But if not, I'll be careful. I'll probably go with this thing. I might just have to put a single phase condenser in and then go to plan B. Plan B would be to basically give myself a couple small mini splits, which I can pretty much run all of the power off the solar during the day, but doing the same thing as this, just tap it into the DC bus, and it will, as the DC bus, you know, has energy from the solar, it'll lower the current that's being driven off of the on grid from the AC power. So I should probably leave this plugged in now. I think it's gonna rain anytime real soon if I just leave all this stuff on. So maybe put up more settings in the morning before it gets real hot. Running it as a 2-stage, like down to 45 hertz until it's hot, will I think it definitely likes that, and it cuts way down. I'll have to like maybe make another video later when I have my computer set up to show you guys kind of what I got for readings. I've made a log of when I was changing it, and then I have my testo measurements, so you could actually see what happens. Rob! Sparky, is that Sparky? The one that didn't, I think Sparky's in the house. The one that hasn't finished running this conduit yet. You can see how it just dead ends right here. Yeah. I know he'll like this. Look at this, I'm running that power through an extension cord. It's going all the way over here. And I might get better performance. It's going over. And I have it just tied in actually all right here. That way, because I already had my meter and stuff. See right there, 314 volts combined. I think about 315 is what I saw the voltage on that DC bus. So connecting this one, which is like 345 unloaded, 330 at full wattage. Where's the... I guess you resumed the live chat, or live stream. My phone overheated. So I was trying to show you guys the voltage over here. The DC bus is at 319. Actually isn't going down yet. There's still other stuff connected. Watch, I can turn this on. I still have this thing connected. That single phase motor on it hooked up to 3-phase. It sucks the power out of this. Oh, that's like, can't really, the bad thing about doing that is I'll be actually tapping off of the grid since it's all interconnected right now. Actually, wait, no, there's a diode there. Oop. A fault too, which it does on single phase motors, hooked to 3-phase sometimes. How do I have this? Actually, I wouldn't be tapping off the grid. It would just be sucking down my solar by hooking that up. I have a diode actually in series here. I'm expecting that diode to explode. Let's see, it's just a little, just like an 1/8-inch diode in series. Because I don't know if power from the on-grid going through its DC bus, you know, rectified, connecting over to the other one, you know, if it could backfeed into the solar array. I don't think it will, because solar array, I saw a bunch of diodes in it. So, Rob, there you are. Is that Sparky, Rob? My phone overheated. I had to throw the phone into the fridge. And then when I was trying to look at my video, it kept saying I was still live. I like, wait a minute. Let me hit and it sure enough resumed. Get down to 16 amps, or up to 60 amps. So that means the sun is going down a little more. So basically the way this would work is as the sun comes over the house and hits that array of mine, it'll like start covering some of the energy that this unit would run. And then as the sun starts going way down, see it's way over there now. Now then you start losing the wattage, you know, from the panel. But like I said, because anytime, like, evidently as long as you have light on your solar panels, the voltage is there, but it'll sag, you know, depending on whatever it can produce, you know. It's kind of interesting. So basically it will always put some power into this bus, you know, to some degree until the sun goes way down. So it'll probably start putting power into this at like 10 o'clock or something, and then by 11 o'clock to noon it'll probably put out as much as it can into this and supply like a big chunk of the power. maybe even over 50%, I'm thinking. We'll find out tomorrow. And then as the sun keeps going down at an angle in the afternoon, it'll start be less and less that it's contributing, which means there'll be more and more on the grid. So we're still taking off almost 5 amps off than what the grid would be pulling. So yeah, the wiring, yeah. I mean, right now I'm running, that's what I was starting to show you, Rob, before the phone overheated. The extension cord right now, because my Sparky friend Rob hasn't finished running my conduit. We got to pull the wire. Maybe tomorrow? But anyway, I'm just running an extension cord. Just show you how, you know, cord's going. Over here is right when my phone overheated earlier. And I just have it all bridged together right here off this. And then that cord goes over here that I have here for testing. This is all for testing. But I'm probably going to put an outlet right here so I can always run other stuff when I play around, you know. But other than that, the power going to that's going to be in this knockout. It's going to go to, where is it? Oh yeah, we got to tap into that or change that box. There's a pull right there. Is it 2 in and 1 out? I don't remember what I was thinking. I think I was thinking that it could just come out I don't know. Sparky will clean it up for me. So, but this is my main DC cutoff right up there. And what I did was today was I got home, I just made up a couple extension cords real quick right there to get that panel is in series with that side. And then this panel here is added to the series here. So it's 11 series instead of 10 series. So it's at 300 volts, it's 330 volts. And then the 2 series of 11 is paralleled. So I think they would call that 11S2P. 11 in series and then paralleled. It's 2 of the series is parallel together. Yeah. And of course, if I ever put like another 11 up, that would just add another 50% of the wattage. Pretty much could run a whole AC out that probably. So I know when I plugged it into the DC bus without that, it's plugged in without the grid. With the sun way down like it was when I got home, it kept starting and stalling. So I don't have to worry about it not starting because I'm always going to have the AC hooked up, and then I'm just going to have this hooked up at the same time to the same VFD, and it just taps off the solar as it can. So, all right, so cool. Well, with that, I'll go ahead and terminate the video properly. When I get a chance, I'll go live again inside a little bit or something. Show you guys the readings I was getting as I was stepping down the frequency. Now, that's not going to be as good of a test as when I actually slow the fan down and just do a 2-step. Probably go to 45 hertz with the fan speed at 50% up there. That'll really drop the load down as the TXV clamps down a little bit. And then, I'm going to hook up the other side as a 2-stage, basically. I just got to run the wire, or I think I didn't have enough wires. Got to check it. I might have to get raw fish tomorrow morning. So, anyway. Yep. So with that, guys, I'll catch you later. Like I said, there's good and bad. The good is my, what I wanted to do works. Tying in 2 power sources into 1 VFD. No transfer switch. Nothing really special. But the downside is separate from the solar. Running a 3-phase unit off that VFD seems to not be very efficient in itself. The power on the grid, 21 amps. I know it's hot as shit today, but 21 amps, that's a lot for a 3-ton unit off the 230 volt, power of the utilities. It's a lot. That 3.5 ton over there was running like 5 amps less than that when I checked it yesterday. It was like 14 amps. So that's weird. So if that's the case, and I can't correct it by tuning that VFD, I don't know, it might not be worth doing what I'm going to do. I might have to just put a regular new single-phase unit over there and then start investing in some mini splits that will do what I'm doing here, tapping into I'll tie the DC right into it. I know it'll work. So, anyway, guys, I'll catch you guys later.